Hi everybody, today we're going to talk more about the proofs that we were looking at last class. So we're on page 25 in your packet. Again, if you need a copy of this packet, I have them in class. If you are at home for any reason and you need a copy, I can put one in the purple bin out front. All right, so conditions for special parallelograms, aka proofs, because again, these don't look like our typical proofs we were working with before. So give this warm up a try. It says given A is -3,5 and B is 1,2, find AB, which is the length. And I didn't give you a graph, so let's practice with the distance formula. And remember your distance formula. Think of the smiley face. Okay, so you do x2 minus x1 or x1 minus 2, x2 doesn't matter, plus y2 minus y1. So you subtract your x's, subtract your y's, square them, add them, take the square root. Now I said it doesn't matter, just make sure that you keep the same order. So what I'm going to do is I'm going to say -3 minus 1 squared. And since I did -3 and 1, I'm going to have to do 5 and then 2. So 5 minus 2 squared. This is the same exact answer you'd get if we used Pythagorean theorem, but because we don't have a graph, it's kind of tough to use Pythagorean theorem. Okay, so let's simplify it down. You can, if you want, put that whole thing right into the calculator and go from there. So -3 minus 1 is -4, and you want to keep that in parentheses, because if you type -4 squared into your calculator without parentheses, it'll do 4 squared, and then tack the negative on. All right, 5 minus 2 squared is 3. All right, so we still got our face going on here. 16 plus 9 is 25, and the square root of 25 is 5. But again, you could have put it into your calculator right from the get-go to get 5. Okay, so that's the length of AB. Again, if you would have done this on a graph, you would have got the same thing using Pythagorean theorem. All right, slope. Remember, that's y minus y over x minus x, or rise over run on the graph. All right, so I'm going to do y minus y first. So 5 minus 2, or 2 minus 5, it doesn't matter, just be consistent on the bottom. Since I started with 5, I have to start with -3 minus 1 on the bottom. 5 minus 2 is 3. -3 minus 1 is -4. And there's your slope, -3/4. It doesn't matter where the negative is. So on the graph, you'd be going down 3 over 4. All right, so here's the way, there's different ways to prove each of these. So first of all, to prove a rectangle, I've broken it down. You can show it's a parallelogram with one right angle, or you can show it's a parallelogram with congruent diagonals. Now let's look back at a parallelogram though. Way back on the first page. Okay, so parallelogram, you can show opposite sides are parallel. So that would be slope. You can show opposite sides are congruent, so you'd have to do either distance or Pythagorean theorem 4 times. Opposite angles are congruent, which you're really not going to use these at all unless they give you angles. So 4 slope or 4 distance, basically. Or you can show the diagonals bisect each other. So that would be 2 midpoint if they give you the diagonals. Okay. I personally tend to go with the 4 slope, but we'll look at all the different ways. Okay, so let's go back down. Again, we're on page 25. So for this, if you show it's a parallelogram with one right angle, if you show that 2 consecutive sides are perpendicular, what I mean by that, so if I showed this side and this side are perpendicular, I would show there's a right angle. And to show perpendicular, you would need slope. So if you want to prove that that something's a rectangle, you could just do slope 4 times. So you could do the slope of the top and bottom to show that they're the same and parallel. You can do the slope of the 2 sides to show that those are the same, and which means they're parallel. And then you could show that, which you've already done the slopes, show that 2 of the consecutive sides, or the sides next to each other, have negative reciprocal slopes, and you've proved it. Another way to prove it, you could show it's a parallelogram with congruent diagonals. So you could show that the length of the diagonals are the same, because remember, that's one way to prove. So you could show congruent diagonals. And then to show that it's a parallelogram, you could show that the diagonals have the same midpoint. All right, so you could show basically, I'm going to use the line feature because you know how well I draw lines on here. All right, so if I look at the 2 diagonals, if I show that that and that are have the same midpoint, so if I show that this point's the same on both, I've proved it's a parallelogram. If I show that these are the same length using either a squared plus b squared equals c squared or distance, then you've shown both. Now, you might say, well, that seems faster, but a lot of times it's not just going to be a rectangle. Let's look at a rhombus. A rhombus, you want to show it's a parallelogram with 4 congruent consecutive sides. So you could show that all sides are the same. So you could do distance or Pythagorean theorem 4 times. The only thing is, if you do that, if it has something to do with a rectangle, it's not, you're going to have to do something else there. You could show it's a parallelogram with perpendicular diagonals. This is the one I like to use. So if you show that the slopes of the diagonals are perpendicular. So again, let me draw my diagonals. It's faster when we're in class at the board, but that's okay. So you could show it's a parallelogram by doing your 4 slopes of each side, like we did above. And then you could do the slope of each diagonal and show that they're perpendicular, they form a right angle. Or you could show it's a parallelogram in one of those ways and show the diagonals bisect the angles. We don't know anything about the angle measure, so you're rarely going to use that unless they only use if they give you angles. But that is rare. You're not going to see that much. All right, and then the last part of this, I guess we're not getting into squares yet. We'll worry about that later. Okay, so determine whether the conclusion is valid. If not, tell what additional information is needed to make it valid. It wants us to show this is a rectangle. Well, it shows that there's opposite sides are parallel, so it's showing it's a parallelogram with 1 right angle. So if you look, this page is going to come in handy. It shows it's a parallelogram because the opposite sides are parallel. Which we can find with slope, and it shows it has a right angle. So is it enough? Yes. All right, it's a rhombus. It's only shown that 2 consecutive sides are the same. So it proved it's a rhombus, but it didn't show that it's a parallelogram. Because remember, it's got to be either opposite sides are parallel, opposite sides are congruent, there's just not enough information. So in order to show it's a parallelogram, you could show that you could find the length of all four sides and show that those are congruent in order to do this. Okay, so let's look at one in action. And again, yes, these are long. It's okay. Let's do it using the graph. It says, given the points, determine if EFGH is a parallelogram, rectangle, rhombus, or square. And I didn't mention this before, but let's put it up here. A square, in order to prove a square, you need to, if it's a rectangle and a rhombus, so if you've shown it's a rectangle and a rhombus, then it is a square. So again, for me, I like to show that opposite sides are parallel, that we have a right angle, and that diagonals are perpendicular. So if you do all 6 slopes, it will cover all of those things. It will tell you if it's a parallelogram or not. It'll tell you if it's a square, a rectangle, or a rhombus. If it's not a rectangle, but it's a rhombus, it's not a square. If it's both, it's a square. If it's not one of those, it's not a square. Okay, so let's plot our points. -4, 1, so go back 4, down 1. Don't forget to label the letter, because we need to keep our work organized. -3, 2, back 3, up 2. 3, 0, and again, if you have trouble plotting that, 3 is in the x spot, so 3 is on the x-axis. And 2, -3. That's h. All right, let's connect the points. All right. Now, you can't just look at it and say, it's not a square, look at it. You can tell it's not a square. That doesn't work. You got to prove it. So you got to show all of these. Again, it says determine if, show if, prove, all of those things. All right, so here we go. Actually, what do we got for time here? I know it's kind of long, but these are kind of long. All right, let's get it done. So I'm going to show you my favorite way. I'm going to use 6 slopes because it will take care of everything. All right, so let's just start. We're going to find the slope of FG. So for FG, remember, it's rise over run. So you have to go down 2 over 1, 2, 3, 4, 5, 6. So that simplifies to -1/3. Okay. Now I want to show that EH is parallel to it. So I'm going to do the slope of EH next. Or HE, it doesn't matter. Either way, you always go from left to right. So to get from E to H, we're going down 2 over 2, 4, 6. Equals -1/3. So those are parallel. So you've shown one set of parallel sides. Now let's show that the other 2 are parallel. So FE and the slope of GH. All right, now again, how I'm writing this, lowercase m represents slope and then subscript for what line you're talking about. All right, so FE, even though I wrote it that way, you want to look at, or you can write EF, it's the same thing. We're just showing, this way it's organized so you know what's what. Always go from the left. Decide if you're going up or down. We're going up 3 over 1. So the slope is 3 over 1. from H to G. Again, we're starting with H because it's furthest to the left. We're going up 3 over 1. And remember, you're saying it and doing it. If you're like, I don't know if it's 3 over 1 or 1 over 3, you're going up 3 over 1 and you're writing over 1. Since those are the same, they're parallel. So we're just going to make a statement. E, F, G, H is a parallelogram. And remember, you can use the parallelogram symbol. It's just looks like the parallel symbol, but then connect the top and bottom, is a parallelogram because we went with the opposite sides are parallel. They have the same slope. All right, so we proved a parallelogram. Now we want to prove that it's either a rectangle or not, rhombus or not, square or not. Okay. So to prove it's a rectangle, remember a rectangle is a parallelogram, which we already proved with one right angle. So in order to prove it's a right angle, look at the slopes. So let's look at the slope of FE or EF, which we said was 3 over 1. And then the slope of FG, or any consecutive side, was, we did it up here, negative 1/3. Those are perpendicular, right? They're negative reciprocals. So that means that angle F is a right angle. So EFGH is a rectangle. All right. Now the last part of this, there's 2 ways you could go about it to show that it's a rhombus or not. It's obviously not a rhombus because the sides are not the same length. So you could either find the length of each side of 2 consecutive sides and show that they're not equal, or you could find the slope of FH and GE, the 2 diagonals, and go that way. So I'll go that way just because that's the way I tend to go. Whoops. What's going on there? Let's erase that. Let's grab the line this time. But again, you could also do distance to show that it's a rhombus or not. If you want to quickly do the Pythagorean theorem, 6 squared plus 2 squared equals x squared, and show that the 2 sides are not congruent, and so it's not a rhombus, you can do it that way. Or you can show that these 2 lines are not perpendicular, because a rhombus has perpendicular diagonals. All right, I'm going to switch colors on here just to keep it organized. So get out of there. I'm going to show the slope of FH, and we can see that we're going down 2, 3, 4, 5 over 2, 4, 5. 5 over 5, negative 5 over 5, which is the same as negative 1. For E, the slope of EG, we're going up 1 over 2, 4, 6, 7. Negative 1 and 1 over 7 are not parallel. Not perpendicular. They're not negative reciprocals. So therefore, EFGH is not a rhombus or a square. And you're done. You could have, like I said, done your Pythagorean theorem here. You could have said, 2 squared plus 6 squared for FG, and show that that's not the same as 1 squared plus 3 squared, and therefore it's not a rhombus or a square. You have almost too many options, but I like to do the slope because it shows you can figure out all of them pretty easily. All right, we're going to save this one for you to try. So this is your only practice question on this. This is your homework. After this video, it says quadrilateral MATH has coordinates that are given. Prove that it's a rhombus, but not a square. So again, the easiest way to do that would probably, because a square has 4 congruent sides, so does a rhombus. If you just stick with your 6 slopes like I did above, of the 4 sides, you don't have to go through the rectangle part. You could just show that opposite sides are parallel to show that it's a parallelogram, and then show the diagonals are perpendicular to show it's a rhombus. So give that one a try, and we'll see you tomorrow. Have a great day.